Hi, now we will look at tutorial 2 of polynomials. So in the previous tutorial, we have learned about the remainder theorem and how to apply it if the divisor is linear. But what if the divisor now is not linear? Let's say it is quadratic in this form. Okay, so you have to use this formula. Well, this formula actually comes from the same formula that you have seen before, which stands for polynomial equal to the divisor times with the quotient plus with the remainder. Okay, so this is the quotient, and this x minus a times x minus b will be the divisor that we have factorized, and the last one is the remainder. So if the divisor is quadratic, our remainder will be linear. Divisor is quadratic, then remainder will be linear form. Okay, so in the previous tutorial, since our divisor is linear, so the remainder is just a constant. Okay, right, so let's look at the example. Given the polynomial and is divided by this quadratic divisor x squared minus 1, the remainder is 2x plus 3. Find the values of p and q. Okay, so to solve this question, you have to remember the formula given, highlighted with yellow here. We start by writing down the formula. The general formula. Okay? And then, since the divisor given is x squared minus 1, I will replace it with d. And since I know that if my divisor is quadratic, so my remainder must be linear. And what is the general form of a linear equation or linear expression? Is just ax plus b, right? Or you can also write it as mx plus n. So it's up to you. For this question, I don't have to write ax plus b or mx plus n because the remainder is given, which is 2x plus 3. So I just have to write down the remainder, which is 2x plus 3. Okay? And then, for the divisor, look at the formula highlighted in yellow. Since the divisor is quadratic, we have to factorize it first. Okay? So x squared minus 1, when you factorize, you will get x minus 1 times x plus 1 times with the quotient. We don't know what is quotient yet, so we just leave it like that. And then plus the remainder. Okay? Now, what to do next? You can look at the divisor one by one. After we have factorized the divisor, we see that the divisor is obtained by x minus 1 times x plus 1. So we can simply substitute in the value of 1, because x minus 1 here, if you equate to 0, is just 1. And then from here, x plus 1, if you equate it with 0, you get the value negative 1. So from that, we can just use p1, substitute in this value into the polynomial, and then what you get is 1 minus 1, 1 plus 1 times qx plus with the remainder, and the remainder you have to substitute x with 1 plus 3. Okay, so since 1 minus 1 is 0, so everything else which multiplied with the 0 will be 0. Okay, So what's left is just 2 times 1 plus 3. That's 5. So the other one you will get is from the other factor. Look at the other factor. You know that it comes from x equal to negative 1. So substitute into the negative 1 and then substitute your x inside the formula of polynomial. Negative 1 minus 1 times negative 1 plus 1 times qx plus 2 times negative 1 plus 3. Okay, so negative 1 plus 1 here will be 0. So everything else there would be 0. 2 times negative 1 plus 3 is just 1. So from here, you have obtained two equations. The two informations that we have obtained is P1 equal to 5 and also P negative 1 is equal to 1. Then what do we do next to find the values of P and Q? Well, you know the polynomial of Px is as given. So since we know that P1 is equal to 5, what we can do next is we just have to substitute in the value of x, 1 into the polynomial. For example, like this. For substitute 1, substitute here, 1 cubed plus p times 1 squared plus q times 1 plus 5 is equal to 5. And then simplify your equation until you get the answer. After you have solved this equation, you find out that you are stuck here. P plus Q is on the left side and everything else is on the right side. So when you are stuck, just leave it there and label this as the first equation. Next, do the same for the next information that we have obtained. Substitute in negative 1 into the polynomial. After you have replaced the x with negative 1 into the polynomial, the answer is equal to 1 because we have found what's the remainder. Now, just simplify and find the next equation. We are stuck here because it's just p and q on the left side and a number on the right side. So this will be your second equation. Now we have two equations, first and second. We can solve it simultaneously. Remember how to solve simultaneous equations. Look at the first equation and second equation. We have q, positive q here, and negative q here. So if you want to eliminate q, we can simply just use 1 plus with 2. Because by adding these two equations, you will eliminate the q variable. So just write the two equations on top of each other and plus the equations. The top equation is the first equation. The second equation is the below part. And then you have to add these two equations. P plus P is to q minus q is 0. And then negative 4 plus 0 is just negative 4. So P, to find P, just divide with 2. Negative 4 divided with 2 is negative 2. You have obtained your answer for P. To find your answer for Q, do the same. You can just substitute in P into equation 1 or equation 2. It's up to you. So let's say I want to substitute into equation 2 because it just looks easier. P minus Q is equal to 0 is the second equation, and then I substitute in the Q value. The P value inside. So what would be my Q? Q is just negative 2. And that's your answer. Make sure that you have answered all of the question. Refer to the question again and read it again. Find the values of P and Q. So we have found the values of P and Q. So example 1 is done. Now look at example 2. It is a little bit more complicated, but it's not hard. Let me show you how. The polynomial px gives a remainder of 3 when divided by x minus 3, when divided by x minus 2, and a remainder of 5 when divided by x minus 4. Find the remainder when px is divided by x minus 2 times x minus 4. Always check the type of the divisor. Is it linear or quadratic? Well, since we have two linear factors multiplied together, so this means the divisor is quadratic. Remember, when the divisor is quadratic, what will be the remainder? This means the remainder must be linear. If the divisor is quadratic, remainder is linear. If the divisor is linear, the remainder will be constant. You have to remember that. Okay, now start by writing down the general formula of a polynomial. So px is equal to qx times dx plus with rx. Or you can write these two terms in the opposite direction. Next, substitute any information that you have. Now the divisor is already given, which is x minus 2 times x minus 4. Replace the divisor with the information given. And then, since we know that the remainder must be linear, what is the general form of a linear expression? A general form of a linear expression is just ax plus b, or mx plus n, according to the formula given in tutorial 2. So let's say I want to write this as ax plus b. So to find the remainder, which is linear, I just have to find the values of a and b to find my remainder. Okay, so this is our general formula of the polynomial. Next, look at the other information given in the question. It says that the polynomial gives a remainder of 3 when divided by x minus 2. Remember our first tutorial. When we divide with x minus 2, that means x is equal to 2 here, because it comes from x minus 2 equal to 0. Then you get x equal to 2. So when you replace x equal to 2 into the polynomial, what you will get is just remainder 3. The next information given is remainder of 5 when divided by x minus 4. So what you get here is the information that when we place x minus 4 equal to 0, x equal to 4 into the polynomial, your answer will be remainder 5. Next, just substitute in your informations into the general formula of polynomial that we have just written down. Start with 2. So this would be qx times 2 minus 2, 2 minus 4, plus 2a plus b. And the answer is equal to 3. So here, we see that 2 minus 2 is just 0, so everything else multiplied with it will be 0. So what's left is just 2a plus b equal to 3. Do the same for the next information. Substitute in 4 into the general formula. So this would be qx times with 4 minus 2 times 4 minus 4 plus 4a plus b equal to 5. And remember, since 4 minus 4 is equal to 0, everything else will be equal to 0. And we are left with 4a plus b equal to 5. Now, we are left with these two equations. So label them as equation 1 and equation 2. You can solve them simultaneously. look at the variables. I have positive 1b here and positive 1b here. But at A, it's 4 and 2. So the easiest way to eliminate variable would be to eliminate variable b by equation 2 minus equation 1. You can also do it with equation 1 minus equation 2. But since I know that equation 2 has a larger value of constant A and I don't like negative numbers, so I just take equation 2 minus equation A. So start with equation 2. Write down all of the equation 2 and then write down equation 1 underneath it. Make sure the position of the variables is accordingly. And then put a big bracket there and write a minus sign. So 4a minus 2a is 2a, b minus b is 0, 5 minus 3 is just 2. So what is your a? A is equal to 1. Next, to find b, we have to substitute a into the first or the second equation. And since I don't like to deal with large numbers, I prefer equation 1 because it's just 2 times a, not 4 times a. Write down the first equation and then substitute in the value of a. So what is your b? B is equal to 3 minus 2, so it's just 1. Well, are you done? Even though you have found the values of a and b, but you are not answering the question yet. Look at the question again. Find the remainder when px is divided by x minus 2 times x minus 4. So the question wants you to find the remainder, not the value of a and b. So the remainder that you have written down is ax plus b. So make sure that you write your final answer in that form. So the remainder is x plus 1 because we can also write this as ax plus b and then replacing a with 1 and b with 1. So that's why you get x plus 1. So write your answer in this form. Okay, thank you for watching.